Dear students, welcome and thank you for tuning in to this video with me, Dr. Loay Al-Zube. Today I'm going to have another quick video about biomechanics. This is lecture 4. And we started talking about chapter 2. We talked about the concepts of analyzing human motion, and we talked about the reference planes and descriptions of the geometry and the structure and the configuration of the human body. And we talked about the problems that are studied by biomechanists. In this video, I'm going to go through the difference between a qualitative and a quantitative analysis or approaches in human motion analysis for biomechanics, and how to formulate a question for a qualitative analysis of a human movement. This class is for biomedical engineers, and as engineers we always like to work with the quantitative quantities. However, we need to understand the concept of a qualitative analysis that are actually the concepts that are used by physical therapists, coaches, and exercise sciences fellows. I always keep telling my students that as a biomedical engineer, we need to serve our clients, and our clients are not patients. They are healthcare providers like physicians, physical therapists, occupational therapists, and even coaches. What is the difference between the qualitative and quantitative in a human motion analysis for biomechanics, and how can we formulate questions actually for a qualitative analysis of a human movement? This is very, very important for us. So let's start. I will start by talking about reference systems that are used in human motion analysis in biomechanics. So they are useful we need to have a reference system. So if you are doing any analysis in biomechanics, you need a reference, and they are used to standardize quantitative descriptions of a human motion. So quantitative and as well as qualitative to some degree, and I will explain this in a bit. So what we want to have, usually we have two-dimensional or three-dimensional coordinate systems, and the most common one used is the Cartesian coordinate system. However, in a lot of our analysis, actually for human motion analysis, we use angular systems, and we'll talk about this as we move on. So the location of the human motion joint centers is the first very important location that we needed to be able to identify and look at and discuss. So it is measured with respect to x and y in a two-dimensional analysis, and if we use the z-axis is going to be for a three-dimensional analysis. And we are going to look at a lot of points on the human body if we are going to do the biomechanical analysis or the analysis of human motion analysis. So people look at the joints, people look at the center of masses, but we will focus on the joints for a bit, and we'll talk about this as we move on. So a quick example, you can look at this schematic, and if you want to see the Cartesian coordinate system here showing the coordinates of the hip in x and y, and if you can see, this is our hip of the subject, and we are looking, we need to measure it, what is the distance between the hip location and the 0 point on the x-axis, and what's the distance from the 0 point to the y-axis. One thing that's important I want to tell students is actually we need to identify the reference point. So the reference point, so if you are in a human motion analysis lab, you need to do something called calibration at the beginning to identify that point, that reference point, and then you measure things from that point. You can measure in centimeters, in meters, or in inches and feet. But calibration is the very first thing that you need to do before doing any experiment to analyze a human motion. And we're going to use and do some calibration in the lab before we set to work. One quick thing that I want to remind everybody with is that in our reference system, we have positive and negative values. So if you are identifying a reference point in the space, this is a two-dimensional space, we know that which coordinates in x and y positive and which is negative in the four quadrants of the Cartesian coordinate system. This is something we need to know, even if you remember the exercise that we did in the class. And when we identified the ranges of motion, we give, let's say, the range of motion of the elbow. We said, okay, we have 15 degree or 20 degrees, and then you said that it is in the sagittal plane and with reference to longitudinal axis. that's good, but it's also, you need to add also positive or negative value. Is it in the positive or the negative? So where do you put your coordinates when you analyze, let's say, the range of motion of the elbow joint? I always tend to tell my students, you put your coordinate system on the joint itself, in the center of the joint, and then you can identify your reference axes and reference planes, and then you can have exact description of what is it that you are sorry for that. What is it that you are trying to measure? So another so if we have the Cartesian coordinate system, we know what we're talking about, we can move now to qualitative analysis. So for qualitative analysis, what does it mean, and what does that entail? So for a qualitative analysis of a movement required the knowledge of two things: the biomechanical purpose of the movement that the subject is actually performing, and then we need to have the ability to detect the causes of errors. So there are two things, which is, now we are talking different from quantitative analysis as engineers. For qualitative analysis, you need to identify what is the purpose of the movement or the motion, and then can we detect causes of errors that can, let's say, cause injury. That's very important for us. And coaches, teachers make judgments and recommendation, qualitative judgment and recommendation on daily basis for their students and also for the players that they are coaching. So this is something different from an engineering point of view and engineering mentality, but it is very important in the clinical setting that we as engineers are able to communicate with coaches, teachers, and physical therapists when they do some qualitative analysis. It's valuable. It has a lot of clinical relevance. We as engineers, we want to help them by adding actually quantitative analysis to their daily routines. Keep in mind that qualitative analysis is quick. And one of the examples for qualitative analysis is that one coach, let's say, will tell to one of his or her players that, well, you are getting stronger, right? From my experience and from the biomechanical purpose of the motor task, and by detecting if there are causes of errors, which in this case will be injuries. As engineers, we tend to look into other variables, but all of them together should be coming as one to help the purpose of improving performance and preventing injury. That is the bottom line. You want to improve performance of subjects or athletes, and then you want to prevent injury. So, what is qualitative analysis, and what is the thing that we need to be aware of to be able to have some meaningful qualitative analysis? So it's a good command of language. And that's standard reference terminology. That's also important. And joint movement terminology is essential for accurate description of a human movement if it's qualitative. This could also go to quantitative, but we will focus on qualitative analysis. Language, that we need to speak the same language as coaches and exercise sciences and fellows and physical therapists. You can't say that I am having, let's say, 15 degrees in the elbow joint range of motion without telling them which plane and to which reference, what is your axis of reference. We need to make sure that we know the command of language, the standard reference terminology, and the joint movement terminology used by our clients. As an engineer, we need to make sure that we speak the same language with our clients. Visual observation is the most commonly used approach for qualitative analysis of the mechanics of human movement, because coaching and physical therapists, in the clinic, they are watching and observing their patients or their athletes. So visual observation is very important. We need to have some prerequisite knowledge before we can say that we can do meaningful qualitative analysis. As I mentioned before, you need to know what is the purpose of the skill or the motor task that has been done, and what are the causes of the technique errors, right? The movement, of the subject, causes of injuries, and how can knowledge about the biomechanics of a motor skill be gained. So these three things, the three questions, need to be answered actually and discussed before we can say that we have some sort of meaningful qualitative analysis. The purpose and the cause This is something with experience and training about the knowledge. So how can we get knowledge? So ways to gain knowledge. So if you are a biomedical engineer and you are interested, let's say, in studying people who play volleyball, you want to study them injuries and then find better training exercises for them. So how would you learn about what is happening in volleyball? The way you gain experience by performing the motor task. You are a player yourself, or reading available material, textbooks, and attending conferences and workshops. This is the only way that you can learn the terminology and the language and be able to do some meaningful qualitative analysis. If we want to do the first step, which is planning of doing this analysis, you need to see what is the question to be answered. And we talked about this in the class in one of the exercises that we've done. So if you're looking at a picture of a cyclist using his playing, doing the rounds with the cycle in a competition, can you come up with a question that you need to answer? So one of these questions would be, what is the effect of the upper body posture on the resistance of the air, which is resulting in the speed of the subject? So how would the posture of the body affect the speed of the cyclist with the posture? Then from what perspectives, such as angle and viewing distance, should the movement be viewed? That's another thing when you do the observation. So here we're adding a little bit of quantitative analysis to the qualitative analysis, because you're adding angles and the distances, right? So this is now numbers. And how many times should the movement be observed? The repetition. So the subject should do this 5 times, 10 times, or 20 times. So all of these things are actually in the planning phase. Also in the planning, you need to, if you want to do the qualitative analysis, other factors that influence the quality of observation is the performer term, so what the performer is wearing, the nature of the surrounding environment, lighting condition, background, all of this has an effect on the subject, and then visual observation versus using a video. And we will do a couple of experiments about how to use free software that can help you, if you have a video, how to do some qualitative analysis. Factors that affect performance of a motor skill: the performer age, gender, anthropometry. So anthropometry, it is the study of the proportions of the body parts and the structure, development and skill levels at which the performer is operating, any special physical or personal traits that may impact performance, and emotional state of the performer. So all of these actually affects the qualitative analysis that you are going to perform. Tools for measuring kinematic quantities. Those are actually, we're going to talk about this in more details. These are going to be quantitative actually tools that will give you specific numbers. So you can have a video or a film with varying frame rates, the frequency, which is how many frames per second the video has been, how the video has been taken, using reflective markers on joints that can be tracked by high-speed cameras with infrared light rings. This is actually becoming a standard in almost all biomechanical engineering analysis labs and human motion analysis labs. So, and we have one in Mount Union we're going to use and work with. Another thing that I want to do is to conclude my video here is that I want to show you flowchart. I like flowcharts. I love to use flowchart as much as possible because they give you a representation of how things are actually could be analyzed. So in this flowchart, this is a schematic that describes how people will do qualitative analysis, meaningful qualitative analysis. So they start with identifying a problem, and then they will add viewing angles. Again, this is a quantitative, so they're mixing it. I like to call it as a hybrid system. So, and then they're viewing the distances, the performer attire, all these conditions that we talked about, environmental modification, the use of videos. You add all of these, and then you make a decision, which means say that, oh, you need to modify your training exercise to get better, or what you're doing is making you weaker or slower. Keep in mind that whoever doing this analysis, they're not giving numbers. And then you collect observations. So you make a decision based on all of these. When you observe a subject performing a motor task. You make a decision, then you collect observations more, but after telling them to do something or to modify anything. That's visual, auditory, from performance from other analysts. Look at the same videos and make decisions. Interpret your observations, communicate with the performer what you observed and what they need to modify. You can end the analysis, or you refine your question and you refine whatever you want to address, and you go back with the same closed loop cycle. I wanted to provide this video for biomechanics students in order to understand that meaningful qualitative analysis, actually they have a format to be performed, and it's useful. As an engineer, we would like to see where can we help in this cycle. How can we help physical therapists, coaches, occupational therapists, orthopedic surgeons, whoever you're doing something similar? How can we incorporate technology into this mix so that we have more quantitative, repeatable analysis that is helpful to improve performance and prevent injury? Thank you so much for watching if you reach this point, and more videos are coming, so stay tuned. Thank you and bye.